In this lesson, we're going to learn about how to describe univariate data displays. So here are a few displays for univariate data that you are familiar with. We have histograms, dot plots, and box and whisker plots. So we're going to take a look at these type of displays and be able to derive some information just by looking at the shape of the graph. So if you want to pause the video and write down some of these pieces of information about each of these displays, histogram, dot plot, box, and whisker, pause and take some notes. When we graph data, the set is arranged to show how the points are distributed throughout the set. So remember, the distribution shows the spread of the data. And our data can either be clustered close together in a narrow range, meaning it's more predictable, or it could cover a wider range and it could be stretched out across your display, showing a lot of variability, therefore a lot of inconsistency and less able to make predictions. So here's an acronym that we're going to use to make sure that we cover all the parts of the graph that we're supposed to describe. So the acronym is SOCS, S-O-C-S, and S, the first S is talking about the shape. So we're going to look at the shape, talking about the peaks and if it's symmetric or not. Then we're going to identify if there's any outliers. Then we're going to talk about which measure of center we should use, depending on if we have an outlier or not. And then we'll also provide the measure of spread, again, depending on if we have an outlier or not. So let's recall that when you have an outlier, we're going to use the resistant measures median and IQR. These two measures are the least affected by a possible outlier. If we do not have an outlier, we're going to use the mean and the MAD to help describe the data set. So let's talk about the shape of the distribution. Again, the shape, the first S of our acronym SOCS, we're going to talk about the number of peaks the graph may have and if it's symmetric or not. So the shape is going to tell us two things about our data. So here we're going to talk about the peaks, the maximums of our data. Now the data count is clearly higher in a certain section if it does have a peak. So we call it unimodal if it has one clear peak. We call it bimodal distribution if there are two clear peaks. If we have one clear peak and it's at the center of the graph, we call it bell-shaped distribution. And some of you may have heard the bell-shaped curve. So let's take a look at some examples. Here we're talking about somebody's science grades. So to me, this looks like there's one clear peak, so that would be unimodal. In this example with ELA grades, there are two clear peaks, so we call that bimodal. So remember, uni means one and bi means two. Now let's talk about the shape. The three words we're going to use are symmetrical, skewed, or uniformity. It depends on how the data varies. So symmetric means that the left half of the graph mirrors the right half of the graph. If it is skewed, that means the data lies on one side or the other, either on the left side or mainly on the right side, and that is called skewed. Then uniform is where all of our displays are pretty much equal. So here's some examples of symmetric displays. You can see that this is the bell-shaped curve. It is symmetric. This would be unimodal, but when it's unimodal in the center, we call it bell-shaped curve. Now, when we have symmetric displays, the best measures are going to be mean and mad because we will not have an outlier. There's also the U-shaped graph, and it's still symmetric. It's kind of the inverse you can see as the bell-shaped curve. And again, remember, if a graph is symmetric, we're going to use the mean for the center measure and mad to describe the variability. Now let's take a look at skewed right, sometimes called positively skewed. I use the term skewed right. So when it is skewed right, most of the data lies on the left side, and then we have maybe a possible outlier on the right that is skewing the data and pulling the data toward the tail, it's called. So when we have skewed right, most of the data is on the left side, and we have some outliers or outlier pulling the data toward the right. When we have skewed right, we have an outlier. So we're going to use the median for our measure of center and IQR for our measure of spread. Now, let's talk about this statement right here. When we have skewed right, again, most of the data is on the left, but we have some data points pulling and skewing the data, and we have it pulling to the right. This creates the mean being greater than the median. These outliers on the right, the values pulling our data to the right, pulls the mean to become greater than the median. So it's pulling the mean, because the median is our middle number, and the median is going to stay where it is, but the mean is going to be shifted and become greater than the median. Now let's talk about skewed left. So it's just the inverse of skewed right. Skewed left means most of the data is on the right side, but we have an outlier that is pulling the data toward the tail and pulling the data a little bit left. It is skewing the data. This time, the mean gets pulled lower than the median. So when we have skewed left, we have an outlier to the left. All of the data, most of the data is on the right. We have an outlier that's pulling it to the left and pulling the mean to be less than the median. Because again, your median is the middle number, and the median is the middle number, and your mean is getting pulled and becoming less than the median. And again, when we have an outlier, we're going to use the median and the IQR to represent the data. Here is uniform displays. This is pretty much where all the data is uniform across. There are no clear peaks, and all measures will be the same, such as your mean and median and IQR and MAD. So we are going to use the mean and the MAD to describe these measures since there's no outlier. So if we were to describe this is a number of text messages. So we could see that most of the data is on the left side, but we do have a data that's pulling it to the right. So it is skewed right. And I do have two clear peaks, so it's bimodal. In this graph, basketball points, most of the points lie on the right side, but we do have some on the left, and our data is being pulled to the left. And so we have skewed left, and there are two clear peaks, bimodal. And now let's talk about the mean and the median. In the number of text messages, because the data is being pulled to the right, our mean is going to be greater than the median. Sometimes we may see the statement, the mean is greater than Q2. In this example, the mean is being pulled down to the left, so our mean is going to become less than the median. In this example, again, most of the data is on the right, is being pulled to the left, so it is skewed left. And we have one clear peak, we'll call that unimodal. And because it's skewed left, the mean becomes less than the median. In this example, the minutes on its learning, we can kind of see the bell-shaped curve. Now, it doesn't have to be perfect to describe it as bell-shaped, but we can see the image of a bell here. So we're going to describe this, and we don't have to say unimodal because when we use the term bell-shaped, that includes that it is unimodal. So therefore, our mean should be pretty much the same as the median. So let's do a summary here. So when we have bell-shaped, the mean equals the median. When we have skewed left, the data is being pulled to the left, the mean becomes less than the median. When we have skewed right, the data is being pulled toward the right, so this pulls the mean above the median. When we have uniform, we're going to have the mean is the same as the median. Okay, now we're going to talk about a sentence that we're going to use, and you can use this in all your work on your handout or your test, and you can just copy, and it's just going to be a fill in the blank. And again, we're going to use the acronym SOCS. So the distribution is, and right here, we're going to describe the mode, whether it's unimodal, bimodal, and then we're going to describe if it's symmetric or skewed left or right. Then the next part, we're going to tell if there's an outlier or not using our upper and lower fence formulas. So if there's an outlier, we will say that there is, and we will tell what the outlier is. If there's not an outlier, we will just simply say there's no outlier. Then in the next sentence, so we have S for shape, O for outlier. The next one is our center measure. So you're going to tell if we're going to use the measure of mean or median, depending on if there's an outlier or not. So we will say it's mean right here, or median, depending on if there's an outlier, is blank. And then you give the actual value. With a, and again, we're doing the measure of spread, the last S is for spread, and we'll either use MAD if there's no outlier, and we'll use the IQR if there is an outlier. And then you tell what that value is. So it's a simple fill in the blank.